Partial differential equation. A differential equation involving partial derivatives with respect to more than one variable is called a partial differential equation. It is considered a simple equation. Here you can see u is dependent on the values of x and y. Hence, we say x and y are independent variables and u is a dependent variable. We can see one or two examples. X dou u by dou x plus y dou u by dou y equal to 2u is a PDE of first order. Here the second one is a PDE of second order. Third one is also a PDE of second order. We can have notations. P is dou z by dou x, q is dou z by dou y, and r is dou square z by dou x square, s is dou square z by dou x dou y, and t is dou square z by dou y square. How to form a PDE? There are three steps involved. Step 1, we differentiate the given equation partially with respect to x. Step 2, we differentiate the given equation partially with respect to y. And third step, we eliminate the constants using the above two steps. So there are only three steps involved. Let us do an example. Eliminate the arbitrary constants a and b and form the PDE for the given equation. So we have the given equation. We name it as equation 1. Step 1, what do? We differentiate the given equation partially with respect to x. So when we differentiate z, we get dou z by dou x equal to, we are differentiating partially with respect to x. So remember, y is treated as a constant. So when we differentiate, we get only 2 into x minus a on the right hand side. That implies P, from where we got P, dou z by dou x is represented as P, that is equal to 2 into x minus a. Or that implies x minus a is kept on one side and p and 2 on the other side. That becomes our equation 2. Now we once again differentiate the given equation partially with respect to y. So just like we did before, we differentiate z partially with respect to y. We write it as dou z by dou y equal to 2 times y minus b. Remember, x term is treated as a constant, so only y term exists. That implies q. From where I got q, dou z by dou y is represented as q equal to 2 into y minus b, or that implies y minus b is kept on one side, q and 2 brought to the other side. Now from equation 2 and 3, we try to eliminate the constant. That means we are going to substitute x minus a and y minus b as p by 2 and q by 2 into the given equation 1. That is how we eliminate. So given equation 1 reduces to z equal to, see in the equation 1, x minus a is substituted as this and y minus b is substituted as this from equation 2 and 3. Denominator you can see a 4 that gets cross multiplied equal to, right hand side you will get p square plus q square, and that is the required PDE or the partial differential equation. Next question, find the partial differential equation of all the spheres of radius 3 units having the center on the xy axis. So what is the meaning of center on the xy axis? There is no z coordinate. Because there is no z coordinate, we have z minus 0 as 0. So this term is not there. Z coordinate is 0. That is why this. Otherwise, the standard equation of the sphere is x minus a the whole square plus y minus b the whole square plus z minus c the whole square equal to square of the radius. So because we have center on the x and y axis, we have only those terms and the coordinate of z becomes 0. So this is our equation 1. So what does this equation 1 represent? That represents sphere of radius 3 units having center on the x and y axis. So here a and b are the arbitrary constants. Now our first step is to differentiate this partially with respect to x. Remember, y is treated as a constant there. 2 into x minus a plus here 2 into z. Dou is said by dou x when you differentiate partially with respect to x equal to 0. 2 and 2 we can cancel. We can cancel 2 and 2, and when you replace dou is said by dou x as p, we get this term x minus a equal to minus p is said because x minus a is kept on one side. Similarly, when we differentiate 1 partially with respect to y, we get 2 into y minus b. Here, 2 into y minus b. X term is a constant because we are differentiating with respect to y. Then plus 2 is said, we differentiate this partially with respect to y. So you get 2 is said, dou is said by dou y equal to 0. Or that implies 2 into, here we are replacing dou z by dou y as q plus 2 into y minus b. That implies y minus b equal to minus qz after cancelling 2 and bringing terms to either side. Now from equation 2 and 3, we eliminate a and b. How do we eliminate? We replace that into equation 1. So x minus a we substitute as minus b z square, y minus b in the equation we substitute as minus q z square, and z square is already existing, that is equal to 9. Now z square you can see is common from all the three terms. Take the other terms inside one bracket, you get equal to 9. This is the required partial differential equation.